Alright, ladies and gentlemen, today we're going to look at what we call parallel and perpendicular features of an equation. Alright, now in this particular video we're going to focus only on parallel. We will see perpendicular in another one. Alright, now parallel equations, we know if the two equations are parallel if they have the same slope. Ladies and gentlemen, they must have the same slope. Here's an example. We have y equals 3x plus 5 and y equals 3x minus 29. Those two equations are parallel because they have the same slope. Because m right here denotes the slope of the equation, giving that y is isolated. Now, let's look at another example. We have y equals 2x plus 11 and 4x plus 2y equals 12. Ladies and gentlemen, the second equation may not look so, but in order for us to find out what the slope is, we must isolate y. We know the slope for the first one is negative 2, and once we isolate y in the second equation, we find that the slope is also negative 2. Alright, and now, let's find the equation of the line that is parallel to y equals 3x plus 7 and passes through the point negative 5, 1. In order to do so, we know they're going to have the same slope. So we can start writing the next equation, which we do not know. We know it will start y equals 3x plus something. So we write it in this manner. So y equals 3x plus b. b is what I do not know. So I plug in the points, the only point that I have. We know it's x comma y, and we know the slope already. We substitute. 1 equals 3 times negative 5 plus b. And we get 1 equals negative 15 plus b. As a result, b, we do the additive inverse of negative 15, b equals 16. So your equation becomes, of course, y equals 3x plus 16. Now consider the other form, which is the point slope formula. We do the very same thing. Using the only point we have, we substitute y minus 1 equals 3x times the expression x minus negative 5. Hence, ladies and gentlemen, we have y minus 1 equals 3x plus 15, and we do the additive inverse of negative 1, which is adding 1 to both sides of the equation. As a result, we have y equals 3x plus 16. It is the same equation which we got using the slope-intercept form. Now I would like you to try this by yourself to see if you can obtain the line that is parallel to negative 5x plus y equals 7 and passes through 2, 6. Ladies and gentlemen, if you do this work, you should end up with the following. First, you must isolate y, and you get y equals 5x plus 7. Now you use the point you have because you have your slope. And ladies and gentlemen, we have, using the point slope formula, we're going to have y minus 6 equals 5 times the expression x minus 2. As a result, we obtain y minus 6 equals 5x minus 10. And ladies and gentlemen, at this point, we would do the additive inverse of negative 6, and we get positive 6. And we would get y equals 5x minus 4. Alright, now let us consider the other way to do this. If we consider the slope-intercept form, of course, and we substitute, it becomes 6 equals 5 times 2 plus b, and 6 equals 10 plus b, and we do the additive inverse of 10. It is negative 10 to both sides of the equation, and we have negative 4 equals b, and the equation becomes y equals 5x minus 4, which is the same equation we just had. Ladies and gentlemen, now I would like you to try to find the equation of the line that is parallel to, well, it's coming, to 5x plus 3 equals 18, but passes through the point negative 6 comma 1. After that, I would also like you to provide an equation of a line that is parallel to y equals 4x plus 7 and passes through the point negative 1 comma negative 8. That is to be completed and returned to me at the end of class. Thank you very much.